Good afternoon, everyone. My name is Khadija. I'm a software engineer at Google Cloud Composer team, and today I'm going to try to fundamentally change how you deal with task failure. So through this talk, I'm going to show you how to build a system to automatically troubleshoot task failures by leveraging powerful signals coming straight from Airflow and Kubernetes. So how do we get from a failing DAG to a fully self-diagnosing system? So it all starts by understanding the challenge. So first of all, we will start by putting ourselves in the shoes of an engineer and see why is it difficult to run Airflow on Kubernetes. Then we're going to talk investigation and pinpoint what are the main causes of common task failures in Kubernetes. Then we're going to the exciting part, which is how we can actually leverage Airflow to build an automation that does this troubleshooting for us. And then we're going to talk customization, how to adapt this automation for your environment and team's context. And then we're going to see, is it really worth it to spend time on this? Let's start with the challenge. I want to introduce you to our main character. So our main character is named Ahmed. He's a brilliant data scientist. He can analyze complex data, build powerful ML models, and find patterns that change the business. So he's doing developable work, but his superpower is data science, not debugging infrastructure. And this is where the struggle of Ahmed comes, and this is what takes most of his time and prevents him from being more productive. So Ahmed's struggle will be the lens for this entire talk. Now, let's look at the environment that gives Ahmed so much trouble. So his company relies on Airflow to manage its critical workflows. We're talking 1,000 DAGs, multiple DAGs running at the same time. They have critical workflows, and as you know, as the company grows, the workflow complexity scales as well. So that's why they choose to run Airflow on Kubernetes. As you know, Kubernetes provides scalability, consistency, and portability they need. So on paper, everything is perfect, but there is something. Running Airflow in Kubernetes is really complex. Let me explain further. So as you can see, this image, I took it from Airflow documentation. It's an example of architecture of running Airflow on Kubernetes. And as you can see, different components run on different machines, which means besides the problems that you might have within separate components, you can also expect some communication problems. Talking more complexity, I can give you the example of Composer's architecture. So here, first remark, we can make that Airflow database is running on completely different projects than other Airflow components. That means that besides the Airflow issues you can also expect some resource-related issues like CPU being exhausted or memory being exhausted, some issues related to the connection to the database, related to network issues or too many requests happening at the same time. And there might be also some permission issues if you don't provide the identity running this environment, the proper permissions that will be able to run the Airflow tasks that you are actually running. So now let's talk investigation and dive deep into each one of these issue category. We will start with Airflow-related failures. So those are mostly problems originating from your Airflow's code logic and scheduling mechanism. How to recognize them? It's usually from task logs or from Airflow components logs by inspecting logs from Airflow worker, Airflow scheduler, for example. And some common examples of failures are, for example, tag run timeout or task timeout. And the way you can resolve this is just by adjusting the timeout value to match the duration that your task or tag needs to complete. There are other issues. I won't cover all of them, but for example, for task stack in queued state, there is also a common issue that Airflow users are running users are encountering. So for this one, you can increase the parallelism. And if you already have the parallelism increased, but like the number of tasks that are not running, that are running is actually lower than what you've set in parallelism, that means that you need to increase resources, particularly number of workers. So we also have resource-related issues. This one is specific to Kubernetes, and here you might expect problems with insufficient allocated capacities for Kubernetes resources like CPU, memory, or storage. And the way to identify them is either from logs, where from logs of the host of your Airflow tasks. So you can find, for example, out of memory events that was propagated there, or some signals that says that one of the resources is actually exhausted. Or you can also inspect the metrics and see how a certain metric utilization is behaving when your task is running. So an example of failure with its resolution is the out-of-memory issue. And here the way you can resolve it is by either increasing the memory of the pod or distribute your workload to run on multiple pods. So this is an example of chart we've got from cloud monitoring. And you can see that within the time where the task was running, the peak memory limit utilization already exceeded 90%, which means that this task is probably failing due to the out-of-memory issue. Besides that, there might be also database-related issues, as we talked before. So, as we already mentioned, you know that Kubernetes excels at scaling, which means it allows you to set the parallelism to a higher value. But this is not free, because now you can make a lot of requests to the database, and as you know, database has a maximum connection, and if you exceed that, you can expect some of your tasks to fail. So this is one issue. Another one is that fact that Kubernetes is a distributed system means that database is often separated machine from the worker, which means that whenever there is some network issues while your task is trying to make some connection to the database, then this task will fail because the connection will time out when trying to connect. So how to recognize those kind of issues? Mostly from Airflow worker logs. Also, you can inspect the SQL instance resource capacity monitoring. And an example of failure with its resolution is the database connection exhausted. Here you can either increase the number of connections or try to adapt your workload, like to not make many requests at the same time. Moving to permission issues. So here the issue is mostly about missing permissions to the service accounts that's running your environment. So, and when we talk about those kinds of issues, it's mostly permission to talk to the Kubernetes API server or permission to talk to other resources involved in your DAGs. You can see those issues within worker logs, and also sometimes you can use some certain operators that needs, besides the permissions that you set in the beginning, additional permissions to be able to connect to the resource that you're involved in within your operator. Last kind of issues I want to talk about is related to operations running in the Airflow environment. So sometimes you might be running a task on a host that's having a maintenance operation at the same time where the task is running, and this might result in the failure of tasks. Sometimes some maintenance operations result in killing some task executions, and the way to recognize that is just to see in the logs if there isn't any kill signal, for example, or something that indicates that the health of the host where your task is running is not okay. And the way to avoid this is to actually try to handle this conflict between the time where your maintenance operations are supposed to run and the time where the Airflow tasks are scheduled to run. So we've just spent some time in the ground, and you can already see that actually diagnosing these kinds of failure in a massive distributed system like Kubernetes is an expensive, chaotic puzzle assembly. It forces our teams to stop being builders and focus more on troubleshooting. And we cannot scale this way. Like, scaling becomes a little bit tricky. I think that we need to replace this unstructured, inefficient way of knowledge sharing with an automation. And this is where our blueprint comes. So the way I follow to build this demo is I followed mainly 3 steps. So if you want to have an automation, the same way this demo is built, you can start by identifying the issues that mostly causes your DAG failures. So the issues that you encounter more frequently, and once you have identified those issues, you can learn how to identify them, from which components they are coming, what are the main sources where the symptoms of those failures occur, and then you can build an Airflow DAG that does this entire complex diagnostic job for us automatically every single time. Now let's see how is it, what is it looking like. Actually, it's a parameterized DAG, and what we expect to have as an input is the DAG ID you want to debug, the task ID, and the execution date. Actually, you can replace the execution date with the run ID in the case of Airflow 3, because like in my demo, I used Airflow 2, but you can always adapt it to your specific case, and we'll talk about this later in the customization section. And what do you expect to have is a report of all of the issues happening at the same time where your task was running. So talking implementation, this is the graph of the DAG. So the way I did it is that I started by gathering all of the metadata from Airflow metadata database. Examples that I got is, for example, task execution start date, task execution end date, which host is running my task, and other information related to DAG run. And then once all of the metadata that I need is populated from the metadata database, I start launching my verifications. So here I'm focusing on 4 main issues. I selected issues in such a way that that those issues are, I can identify them by fetching information from different sources. For example, the first issue is verifying whether there is an out-of-memory existence. And the way it does it is that it makes some request to a monitoring source. In my case, it was cloud monitoring, seeing whether the memory utilization limit is exceeding more than 80% of the utilization. The second one is finding the missing service account permissions. And it does that by comparing the expected permissions that I expect to have with the current ones. And this is by fetching the identity permissions. In my case, I do it through a gcloud command to IAM. But this is the case of Google Cloud Platform with the Composer environment. You can adapt it to your to your provider or to your architecture. The third case is verifying the DAG run timeout existence by leveraging what we fetch from the get all metadata task group. And the fourth case is verifying whether there is an exception existence. And this time it's from a login source. In my case, it's Google Cloud Login. And then we populate all of those information to XCOM. And we're having a nice report at the end telling us what caused our task failure, along with recommendations. So now let's move to the demo. So here I have a Composer environment with many failure reproductions, and they have also my debugger DAG. So this one, for example, is reproducing the case of out-of-memory issue. And it's doing that by allocating a longer list of strings. So let's say that I want to debug this case. I'm going to need the DAG ID, task ID, and the execution date. Then I will go to my Airflow UI and start launching my DAG. So it's going to need some parameters, as it's a parameterized DAG. I'm going to pass them. Let me just speed up this. So I'm triggering my DAG. So it starts by getting all the metadata, and then it launches the verifications, fetching symptoms from different sources and verifying whether an issue exists or not. It takes some time to be fetched. Now, if I go to the logs of verify OOM existence task, I can see that from cloud monitoring, I've got that the memory limit utilization was 99.42%. So it was almost all utilized, which means that most probably I will have case of out-of-memory failure, task failure, and my task is probably failing due to that. So in the print issue, I provide a summary of the task failure along with a recommendation on how to solve the situation. In this case, I'm recommending to bump the memory or to reduce the load. There are other scenarios that I tested. For example, here there is the case of DAG run timeout, and I fetch from the metadata that the DAG run timeout specified is 5 minutes, while the DAG run needed more time to complete. Now moving to the last case, I can show you that, for example, here, this is the filter I'm passing to my cloud login client. Most of the information from this filter come from metadata that I fetched before, and I'm just combining it with what I have in the input to be able to make a request and see if the issue I'm expecting is there. And you can see that I'm reporting that there was a task, this task failed with an exception. I can even make it better with propagating the failure from cloud login to the report. So you can extend this as much as you want with the issues that you're encountering more frequently. And this is what are we going to talk about in the customization. So if you want to customize this, first thing I would advise is to establish a collaborative knowledge repository where whenever someone learns about an issue, knows how to identify it, and knows how to fix it, they can just extend the DAG and make it automated. Second thing I would recommend is adapting this to your Airflow architecture. As you can see here, as we're using Cloud Composer, this is specific to Composer use case where we're using components like Cloud Login or Google Cloud Monitoring or gCloud, but you can adapt the sources according to what you have in your architecture and where you're running your environment, in which provider. Also, you can scale diagnostics over time. So as you're encountering more issues, you can learn about which sources are worth being added to your diagnostics. Also, you can think about more complex ways to identify the issues. And as a long-term vision, I would suggest to make it an environment-wide diagnosis where you can leverage, for example, the listener plugin from Airflow to listen to your task failures. And whenever there is a certain task fails, you can trigger this DAG, and you can even make it more interesting by leveraging what Christian had in his presentation yesterday and give this to an agent that will be able to give you some suggestions on how to fix it. And probably if you trust the agent enough, you can make it do the work for you. Now, is it worth it? I think yes, because first of all, your tasks will spend more time running and less time failing, which protects business critical SLAs. Also, you have increased engineering velocity. Now your engineers will focus on building instead of debugging. And also you have enhanced team efficiency because new joiners will have an automation tool of all the known issues around the team instead of spending more time asking different people about different knowledge. And also you have a codified scalable knowledge for your team. So you're transforming individual troubleshooting expertise into a centralized, automated, and shared asset that grows with your team's experience. So with that, we're taking Ahmed out of the hook, letting your data scientists focus on science and your engineers focusing on building